Hi folks, this is a tutorial that I'm doing for continuation of performing modal analysis in the 3D Experiences finite element solver, which is essentially the Abacus program. What I do in these tutorials is find certain problems that are done by other users in the other users in YouTube, but employing the Abacus program, and I try to replicate those steps. Uh, in this particular series, I have taken problems that a problem that is done by this YouTuber, and uh, this particular tutorial number 7 is where I model this entire thing in 3 dimensions. Okay. Now, I'm not trying to get the numbers that this fellow is getting because my mesh is completely different, and I'm just showing the steps when you compare the 3D experiences implementation of the program slash Simulia Abacus program and the Abacus CAE program, and to help people solve the problems in 3D experience in a smooth fashion. Now, the, my strategy to do this problem, uh, essentially the geometry shown here, my strategy is to follow a tutorial that I've made in this link, but with one difference. What I do is I basically create the bottom floor as an assembly. And then once I get that, then do a copy paste of this assembly, sub assembly, the first floor into the main assembly, and then move them apart and proceed with the problem. Okay, copy paste, and then apply the restraints, etc. The problem that we are doing is these bottom of these four piles are clamped, and all the joints are perfectly bonded together. So essentially, if you wanted, you could actually solve this as a single part, but that defeats the purpose of this particular tutorial because we're going to solve it as an assembly. However, I would mesh only one of these uh, pieces, one of these channels, and then use it to essentially build the final model for the entire structure. Okay. Uh, just to show you the type of mesh that the YouTuber that I'm using this as a reference for is right shown here, but I'm not even try to uh, be close to these things because the objective is not to match these numbers, the two numbers, it's just to show you how things are done in 3D experience. Okay. All right. So let's go ahead and do this. We are in the 3D Experiences platform. Immediately I save this thing. So let me, first thing that I do is I insert a dummy part here, and its sole purpose is to have access to two direction if I want to linear multi-instantiation to be picked. Now this was done in explaining detail in the tutorial 18 that I referred to it, and tutorial 17, but so that's why I'm going to skip some of the unnecessary steps. So while I'm in this assembly, right click, and I'm going to say one way is to say insert 3D shape, or the alternative is while I'm here, I just click on the assembly tab and say access system. As soon as you do that, it's going to come and say, hey, I'm going to create a new part for you, which is fine. Create a new one. There is a name, and notice that when it creates it, it puts already an access system here. Instead of me making this and then putting an access system here, by clicking on this access system, it automatically creates the part, assuming you say okay and do it, and then you can move on. Now, what I'm going to do is I will create a sub-assembly in there. So while you're on the top level, right-click Insert, Product, and this is going to be the main floor, the bottom floor. Once I'm done with this thing, then I will actually copy and paste this thing to get the second floor and the third floor. All right, so what we're going to do is while we go to this, right there, we go to this sub-assembly, right-click, insert a 3D part, Okay. All right. And this has to be repeated 8 times. All right. Because you can see that there are 4 columns here and 4 beams. Okay. So why don't we do that now? As explained in tutorial 18, while you're here, you put the cursor on this and you click on it and say linear multi-instantiation. And right now it's doing it in the direction Z. I don't want it. I want it to be in direction Y. And I want 8 of them. So I change this thing to 8. And you can change the spacing if this is bothering you. I can change the spacing, but I'll leave it the way it is. And then when you're done, you just left click and it's going to create 8 basically uh, uh, 3D parts, except that I haven't done anything. So I'm going to go and make my 3D part in this first one. So I'll just go to the first one, double click on 3D shape, and then I make one. And every time, because these are replications of that, multi-instantiation, whatever I do here is going to be repeated there. Okay. So on the XY plane, I will sketch, and notice that it's going to do it for all of these. So let me make a rectangle. Okay, a rectangle. Now, the thing is that this is going to be 300 millimeter, but because of what I've done is you're going to go through each other, which I don't like it. So let me move this thing. Let me move this thing. That spacing that I had was not very good. Okay, unfortunately, you cannot change that spacing. So what I need to do, exit. Okay. See, when you select on that spacing, there's not much you can do. Let me go ahead and delete these guys. Oh, is it delete? Can I? Well, obviously you have to be in this assembly in order to delete that sub-assembly. We select these, see these, delete it. Okay, delete it. Let's try it again. I already made my sketch here. Even I'm going to delete this. Okay, so let me go ahead to this part. Delete that. Fine. Okay, let's try it again. Go to this level. Go to the top level. Multi-instantiation. Do it. And the sizing, I didn't like it because this was too close to each other. So we can drag this. See that? See that? Now there's 387. Even further if necessary. And then when you're done 8 of them, you click and you get all 8 of them. You have to be prepared for making things like this. What I originally did, the spacing was so that when I wanted to make that rectangle 300 millimeters, it kind of interfered with these other ones. So let's go ahead and do that now. On the XY plane, I will sketch. Let's go to the part first of all. Go to the part. On the XY plane, we sketch a rectangle, which is 300 millimeter by 300 millimeters. So let me draw it here. Notice that because of change sizing, these are going to be not going through each other, even if you put a 300 millimeter dimension there. So double click on that. This is going to be 300. Fine. Okay, and this is going to be 300. Okay. Now inside of this, I'm going to make a rectangle so that the wall thickness becomes 25 millimeters. So we can dimension it properly. So from here to here, this is going to be 25. From here to here, it's going to be 25. From here to here, it's going to be 25. There we are. And now we exit. And we pad these things by 3000, or this one by 3000 millimeters. Because we did linear multi 3000, linear multi-instantiation that are going to be created. Okay. Now, what I'm going to do is apply material. So let's go create it. While we're in this, we can do it either here or while we are in this physical product. It makes no difference. So let me do it here while I'm there. Tools, create a material, and I'm going to call this thing August 10, 2024. Steel, and say okay. It's gonna create a dummy one here right there. So, and then we're gonna say apply. I can apply to this part or the top level. It makes no difference. I'll apply to the part, and then green check marks. And because we did a linear multi-instantiation, it's applied to every single one of these pieces. All we do is to work in this one. We don't worry about those because automatically it's going to be done. Okay, so now we have to put the values in that. So expand this thing, double click, because all I did was create a dummy template actually. So under density, put down 7850. 7850, that's for steel. Oops, got to do the rest of it. Yeah, okay, so density was there, you can see that. And then for abacus multiphysics, mechanical, elasticity, elastic, 210 GPa. 210 GPa, and Poisson ratio 0.3, 0.3. And then we say, okay, good. Now, while we're in this, I'm going to create a finite element mesh. So right click, insert, finite element mesh. So it's going to do it for this, and then automatically it'll do it for these other 8 pieces. And if you double click on that, it puts you in the finite element basically, the mesher module. You click on the mesh tab. We're going to do a sweep mesh, and we're going to select this part body. It makes no difference. And I'll do size 20 millimeter and 40 layers. And I say mesh. It's going to look like that. Notice that this is substantially different from what this fellow is doing. And that's why we're not going to even try to match values, but that's okay. And now we create a solid section, select it on the properties right there, properties tab, solid section, and select the part. Notice that the proper material is picked, and then we say okay. Very good. Well, let's do a quick save here. So these things are all mesh too. They're all hidden. You can see that. If you say right click, for example, hide and show, it'll show the next one. But that's why I don't need it right now. They're all there. They're all there. So let me actually get some of these out in the open, because what I want to do is I want to assemble it. Okay. Now I don't want to assemble, but I'm going to use the snap option. So let's put this thing, for example, rotate it and put it against that. Okay. So what do I mean by this? Notice that they're showing, and then I'm going to say, okay, let's go back to the assembly design. All I have to do is to double click on this, double click on that. We are in assembly design, and here we have move selected component. You click on that, and you move this. Notice that the coordinate system is placed here. I want to rotate this thing by 90 degrees. So if you just double click on that coordinate system, and we're going to rotate this thing about, let me see now, what is this? About this direction. I believe that this is X. Let's check it out. Ah, there we are. Very good. You say, okay. Now I'm going to place this thing on the very top. So here we're going to go and say snap. And what I want to snap is I want to snap this point to that point. There we are. And I repeat this thing until I get all of them in place. Okay, this is done. So let me go ahead and get that one. Hide and show. Okay. And once again, I'm going to click on move selected component. It's this component, and I'm going to move it, translate it like that. Okay. And then I'm going to create a snap between this point and that point. So let's go ahead here, snap between this point and this point. Okay, notice we're not creating assembly constraints here. These are just, putting them in the right spot. Now let's get this fellow out. Let's get some of these other ones out. So let me try. Which one is this? It really doesn't matter. We need something out. Okay, so let's move this. Let me move this thing. Let me move this. Okay, very good. And I'm going to rotate this about that direction. So let's see now. Once again, click on move. Okay, and we're going to click on the coordinate system and rotate it about the y direction. So I'm going to make this thing 0, make the y direction 90. I guess y is, let me see now, not the y direction. Maybe I want to rotate it about this, right? So, oh, this is, okay, so let me go ahead and change that. Let me see now, 90 degrees here. Okay, that's better. Okay. That was about the x direction. Good. So now we're going to snap it. So we go here and snap this point to this point. Okay. Very good. So that takes care of this. And now let's show this one. Okay. And place it in the right spot, or at least in the vicinity. Okay. Remove this thing. Okay. Good. And then we click on the green check mark here and then snap. Snap. There are other ways of doing this thing. For example, you can use symmetry conditions and things like that. So this point to that point. Control Z, because I should have selected them in a different order. Control Z. Okay, good. Let's try it again. Snap. First one should be moving. So this point, well, how about me doing, well, okay, how about selecting that to this? Okay, that's better, because I don't want to destroy the other ones. Remember what I said about symmetry, stuff like that can be done very effectively, but I'm not doing it. I'm just doing some extra work here for no reason. Okay, so let me move this thing. Okay, very good. How about I rotate that? Okay, I'm going to rotate it about X once again, about the X direction. So okay, so let me actually do the following. Let me try this thing, 90, 0. Yeah. Okay, so snap them in the right spot. Snap this point. I want to snap it to that point. Good. And we're almost done. Let's bring this thing into show mode. Okay, and move it to right spot. All right, and snap it into position. So snap this point to this point. Good. And the last piece is over here. Bring it into the show mode, hide and show. There we are. Okay, so let's move it. Sure, this is the last one. Let's move this. All right. And I think we have to turn this thing around. Yep. So click on this corner system. And let's see now. Let's try that. Yep. And snap. I want to snap this point to that point. Okay. All taken care of. So we go all the way to the top, save. Now notice that these are all meshed and you can see that obviously. So what I'm going to do now is this. I'm going to say, copy this, go all the way to the top level. Copy this, right click, copy, and paste. Right click, paste. One is created here and it has everything that we did. They're sitting on top of each other or next to each other. And do another one, right click, paste. Okay, good. Now we're going to move things apart. So for example, let me move them apart again using the compass. I can select this and then move it in the direction that I want, like that. Of course, you have to rotate it. So double click on this and rotate it like so. Nope. Try it again. Yep, that's good. And do the same thing with that fellow. So this is done. Let me move this thing away. Once again, use the compass on this piece, this one, or not that one. Let me cancel that. Try it again. Compass with this piece. Actually, the assembly, not that piece itself. Cancel that. Let's try it again. So find out this is the okay. I want to move that one. Yeah, okay. So compass on this piece. Okay, and move it like so. Oh, and then rotate it. Yeah, I forgot to rotate. Double click. Yep. All right. Now put them together. So what I'm going to do is I'm going to do the snap of, let's see now, this is going to go over there. So I'm going to snap this point. All right. This point to that point. Okay, very good. Let's do the other one. Snap this point to, I think it's that point. Yeah. Okay, so we got it. File save. Now the rest of the problem is very similar to what we have done before. So what I'm going to do is go to the uh, uh, structure model creation. Say yes, it's an FEM model, empty FEM model. Please make sure you watch video 18. It says what are the parts that you want to participate. These three parts I want to participate, and then minimize that, and then include the under the setup. You select this other icon, combining finite element model, and you take one of these, it doesn't matter, one of these, right click and say, select FEM on all instances right there. Please watch video 18, minimize that. Good. And now we're going to find the connection, the connections tab, the detect the tide nodes, tide detection. Make sure you click on leave the tolerance as it is, no problem. Find tides. It finds all the tide nodes. I've done these in detail in tutorial 18. And that's pretty much it. So now we're going to go to the structural scenario creation. It's a finite element model that we created. This one that we put together by making basically, I don't know, 24 copies of that original mesh. Okay, good. And then we're going to do on the procedure, we want a frequency analysis, or what is that? The frequency step. First 10 modes, that's fine. All right, now we clamp these ends. If you don't want to see the mesh, what you can do is right-click Visibility Manager. Don't show me the mesh. I don't want to see it. There's too much junk there. Okay, and then we clamp these bottoms. So we go under boundary conditions. You go to clamp and patiently select these pieces at the bottom. This is one. Here's another one. This is number 3. And there's number 4. And then we say okay. And that's it. Because we're doing natural frequency, there are no loads. Okay. Now, if you don't want to see these planes, you know how to do that. You say Control F and say pick all the planes, plane, and then find and select. And once it's selected, you can hide them. I mean, it's not bothering me, but there's too many planes there. You don't want to see them. Just find and select, and then right-click hide. It just goes away. Okay, good. Before we run it, let's save it. And then we go to simulate. First of all, do a model scenario check. I don't anticipate any problems. There may be some warnings later on because of the size of the elements and things like that. And then simulation check. Fine. Let it do it. Very quick. Let's shoot now. We did it now. Okay. I'm not sure. The type of element is parabolic. You can always change it if you want, but I just wanted to show you the process behind making this relatively complicated piece together. Remember, this could have been solved as a single part, but that really defeats the purpose of the tutorial. It's critical for people who are interested in this, or they feel that I went too fast, to look at tutorial 18 and 17 that I made a reference to in the slide. Okay, there are some warnings here. I understand that's fine. One should get the habit of reading these warnings, become familiar with some of them, but a lot of them have to do with the mesh sizes and things like that, at least in the present context. And when this is done, then we're going to run it and look at the frequencies that are generated and the modal shapes. Okay, this is almost done. Keep in mind, this is real time. I have not, cut any pieces of the video. So now this is the actual simulation, the actual run. It is a rather large model when you think about it. The number of nodes, and these are the number of elements. These are quadratic elements, so there's more than it meets the eye as far as the number of nodes is concerned. These are basically 20 noded parabolic elements. In the description of the problem, I actually said 10 noded Breck elements, but or eight noded break element, but these are actually 20 noded parabolic element. It doesn't matter. I could have changed it. It's running. I would give it another couple of minutes and we should be good. In retrospect, I probably should have changed it to instead of parabolic linear. There would have been a lot less computation to find the frequencies. Incidentally, in tutorial 17 and 18, uh, I didn't do frequency calculation, which is more expensive, obviously. I did a linear static problem, okay, linear static analysis. So I applied the load somewhere in the structure and then found the deflections, etc. But here it's frequency calculation, but that's one reason that it takes taking longer than what I had anticipated. On top of that, parabolic elements, of course. Generally speaking, natural frequency calculation is more expensive than linear static analysis because you have to find it. Yeah, so it's almost done, 100%. Yeah, and then it's going to extract the result, and you can look at the modus. Mhm. Extracting results, almost done. In the playlist that this video is located, I do a variety of problems from that same YouTuber, which we look at the problem in different with different simplification. Okay, so let me close that. So if you this is the first frequency, these are all the frequencies. Now notice that one and two are identical because in different directions. This is a torsional. These are all torsional. This is bending, etc. So there we are. And yeah, that takes care of this tutorial. Good luck.